this example, determine the relationship of the two equations. And the first equation there is almost in slope-intercept form. It's almost there. It's just not quite there, right? So I'm going to change that into slope-intercept form, y equals mx plus b, simply by subtracting both sides 3/2 x. Okay, so I got to do it to both sides. And again, the reason that is because that zeroes out the 3x term, and it allows me to drop the y. So now I have y equals, well, I'm going to switch those two terms, right? Don't combine the 3 and then the negative 3/2 x. They're not like terms that you can combine. But my coefficient of x now I see is negative 3/2. And then we also have the positive 3 there. Okay, so I do have a slope of negative 3/2. And also I have a y-intercept of 0, positive 3. Now, of course, we'll only look at the y-intercept if the slopes match, but we got to go to the next equation and then find or change that one, force it to become slope-intercept forms, which we will now do. So again, I got that minus 3x. I don't want it there with my two y's. I would like to be able to take the two y's and just drop them by themselves. So that means the minus 3x has to be zeroed out as plus 3x. But if I do it to one side, I got to do it to the other side. So negative 3x plus 3x, that zeroes out as planned. Then I've got a positive 3x and a negative 12. Again, don't combine those terms because they're not like terms that you can combine. We're so close to slope-intercept form, but the last thing we need is the coefficient of y to be a phantom 1. Okay, not a 2. I don't want this 2 coefficient of y. So I got to take all the terms and divide them by 2. Okay, so that becomes a phantom 1. My coefficient of x becomes 3/2. And then my y-intercept becomes negative 12 divided by 2 is negative 6. So from that equation, I now have a slope, which is 3/2. And I have a y-intercept at 0, negative 6. So let's look, again, we just got to look first at the slopes. I got a slope of negative 3/2, and I got a slope of 3/2. So a couple things on this one that students make mistakes on. They say it's 3/2, 3/2. It's the same slope. It's either parallel or the same line. No, they're not the same. It is the same numbers, but this one's negative, this one's positive. So just from that, I would probably go in here and just cross out that they can't be parallel or the same line. Can't be. Okay, now then some students make this mistake. They say, well, they're opposites, so automatically they're perpendicular. No, these are opposites, but for perpendicularity, they have to be reciprocated. And this one's 3/2, 3/2 here as well. So it's not been reciprocated, even though they are opposites. So in addition to not being parallel or the same line, it's not perpendicular. And now we know that the actual answer here is that they're neither parallel or perpendicular. Okay, so the slopes, again, don't be fooled by this. They kind of look like they're the same, but they're not parallel. And then they're opposites, but don't be fooled by that being perpendicular. They're not flipped fractions. But notice right here, I didn't actually need the y-intercepts, even though we did identify them. That's because we found out all the information we needed from the slope.